Alright, today we're going to be learning about slope-intercept form and then eventually standard form. Slope-intercept form, you all pretty much know by now, is y equals mx plus b. Okay, my slope is my m, my y-intercept is my b. And I just reminded myself that my y-intercept will always be my starting point. So when I go to start a graph, I always know that this is going to be my starting point, my b. My slope formula is just y2 minus y1 over x2 minus x1. That is my m. So if you ever needed to know what the slope formula was, this is probably the third time you've had it written down in your notes. So remember to look back in your notes if you ever need that. Okay, we're going to do some examples with slope-intercept form. Okay. Something very easy. If I just was given a slope, so first example, I'm given 2/3 as my slope, I'm given 4 as my b, I just simply plug them into y equals mx plus b. From here, I have y equals 2/3 x plus 4. That's just given a slope and a y-intercept, I just plug them in. So that would be a linear equation in slope-intercept form. Again, same thing with number 2. This time I'm given -3 and I'm given -1. I simply plug them in. -3 was my m, -1 was my b. Now I don't have to write +1, I need -1, so I have -1 here. So that would be the linear equation for y equals, given these two things here, I'd have y equals -3x minus 1. Very easy two examples. The next two, a little bit trickier, because now we're not given both slope and b, we're given just a slope and then a point or a coordinate or ordered pair, whatever you want to call it. Start by writing y equals mx plus b. That's what I always do. I start by writing my formula first. Then I plug in what I know. I know I might have my slope as 2, so I'm going to plug that in for m. So I have 2 in the m spot. Then I know from my coordinate I have an x and a y. Okay, so I just plugged in this x. And when I plugged in this x, I put parentheses around it to remind myself I substituted that in from my ordered pair. And then for my 4, I plugged that in for y. Now the one thing I don't know is what I'm solving for is my b. So I do some math. I have 4 equal to -1 plus b, add my 1 to both sides, get b equal to 5. From there, I'm going to plug it into y equals 2/3 x plus 5. That is my b spot, so I'm going to plug that 5 in there. My 2 came from my slope originally. So I just plugged my 2 in front of my x because I know that's where it belongs. My 2 is my m, so it goes in front of my x. So I have y equal to 2x plus 5. Okay, my next example. I have -2/3 as my m, and then I have the point 3, 5. Same thing. Start with y equals mx plus b, plug in what you know. So I have 5 equal to 2/3 plus times 3 plus b. Okay, that came from my x. The 5 came from my y spot. Okay, then I just did some math. Solve for b. Multiplied here, got -2, added 2 to both sides to get b equal to 7. Went ahead and just rewrote things with what I knew. My m is -2/3, so I have -2/3 x plus 7. Okay, so there is my y equals -2/3 x plus 7. That is slope-intercept form. I could easily graph this if I needed to. Okay, so that's given a point and given a slope using slope-intercept form. The next form that we're going to learn about is standard form. You may have heard of it, don't remember it. That's why you're going to take notes on it. So here it is, ax plus by equal to c. Simply just using an x from a coordinate and using a y from a coordinate, you can plug those numbers in. So these x's and these y's right here are not just generic. They have meaning. They come from an ordered pair. So that is standard form, ax plus by equal to c. This is harder to graph, harder to use to graph. So we like to put things in slope-intercept form in order to graph. Okay? So that's what these two notes right here just reminded myself that we don't like standard form to graph with. I like to use it in slope-intercept form. You may or may not like this, but it's the easiest way for me to use. Okay, so we're going to do some examples with standard form. Alright, first example, we got 3x plus 6y equal to 12. We've done problems like this from the parallel perpendicular foldable that we had. First step, we want to get everything away from our y variable. So first step, we subtract 3x from both sides. When we do that, these are not like terms. So I can't subtract 12 from 3, or 3 from 12. So I'm going to write them side by side. I just wrote -3x plus 12. Over here I have 6y, divide by 6 because I want to get everything away from my y. When I do that, my fraction -3/6 reduces to -1/2 x plus 2. My 2 came from 12 divided by 6. Okay? I know I went fast, but it should become that easy now, doing the simple mental math. 12 divided by 6 is 2, -3/6 reduced to 1/1/2. That is my slope. That is my y-intercept if I needed to graph. So these two lines right here are the same. I just simply rewrote this in slope-intercept form. So these two lines are the same. They're just written in different forms. Okay. Number 2, this time I don't have anything in front of my x, so I'm going to just do the same process, same steps. Subtract x from both sides. You're left with -2y equal to -x minus 5 divided by -2. When I do that, I set myself up right here just to see what I had left. I have -x divided by -2. There's an imaginary 1 in front of that x. When I divide -1 and -2, they don't divide evenly. So I'm going to leave it as 1 over 2. And then my signs are the same, so I'm going to have positive 1 over 2. And then I move my x off to the right just so I can see what my slope is. So this right here is the same as this. I just rewrote it so I have my slope and then an x. The next thing, I have -5 divided by -2. Again, my signs are the same, so I need a positive 5/2. 5/2 does not reduce, so we'll leave it as a fraction. Then I labeled y-intercept, and my slope is 1/2, which we already talked about, so we have y equal to 1/2 x plus 5/2. Very easy for me to graph this as compared to what I originally had. And again, these two are the same, even though they're written in different forms. Okay? So we've got 2 more examples, trying to get a little bit more experience with these. They don't get any harder, but you do have to be careful of your signs and of your fractions. Number 3, subtract 2x from both sides. Okay, we have 2x minus y equal to 6. This time I had nothing in front of my y except for a minus sign. So that will come into play eventually. We subtract 2x from both sides. And then this is where it comes into play. We want to get rid of this negative. Minus and negative are the same thing. Don't forget to bring it down, but then we need to get rid of it. So I divide by -1 into everything. I divide by -1 because there's a 1 in front of my y and there was a negative. So I divide by -1. When I do that, I have a positive 2. My signs are the same. I have a positive 2x. My signs are different, so I have a -6. So I have y equal to 2x minus 6. My 2 is my slope. My y-intercept is -6. That whole thing is my y-intercept. So these two lines are the same. I know this is standard form. This is slope-intercept form. I can easily graph this using my y-intercept and my slope. Okay. The last example, number 4, we have bigger numbers. No different process, just bigger numbers. So we're going to subtract 10x from both sides, given 10x minus 12i equal to 14. Next, we'll just divide by -12 into everything. Then I, again, set myself up just to see my fractions here. -10 divided by -12. The number that goes into both is 2, so I divide 10 by 2 and 12 by 2 to get 5 and 6. And then I saw my signs were the same, so this is going to be a positive 5, 6. Same thing with my other fraction over here. I have 14 and -12. Number goes into both would be 2. So 14 divided by 2 is 7. Just positive 12 divided by 2 is 6. Then I looked at my signs. They were different, so I need a negative out in front. Okay, so this is my y-intercept. This is my slope. That is the slope-intercept form of this standard form line. Okay, all I did was just reduce my fractions because when I would go to graph, I don't want to be counting bigger numbers. I want to count smaller numbers. That way it's easier to graph. So I can easily graph this slope on a small graph. So that is slope-intercept form and standard form of linear equations.